Trigonometric identities. There are many trigonometric identities. In class 10th, we learn some of them. The first one which we learn here is sine square theta plus cos square theta equal to 1. Sine square theta plus cos square theta equal to 1. So let us take angle C as theta. Now we'll prove this identity. So first of all, let us find the value of sine theta. What is sine theta? Sine theta is defined as perpendicular by hypotenuse. So now the side opposite to theta angle is AB. So perpendicular will be AB and hypotenuse, is always the side opposite 90 degree. So that will be AC. And similarly find cos theta. Cos theta is defined as base over hypotenuse. And what is base? The whichever angle which we have taken, suppose here in this case we have taken theta. So other than the hypotenuse, the other side will be known as base. So in our case, base will be BC. So BC over hypotenuse is AC. Now what we are going to do is we will just put the value of sine theta and cos theta in the left hand side of this identity and check whether sine square theta plus cos square theta is 1 or not. So let us check it out. Sine square theta plus cos square theta is equal to, putting the value of sine theta, will be getting AB over AC and square is there, so AB over AC whole square plus cos theta is BC by AC, so cos square theta will be BC by AC whole square, and we'll now simplify it. So this can be written as equal to AB square over AC square plus BC square over AC square equal to AB square plus BC square over AC square. Now if we see the figure which we are having here, AB square plus BC square will give us AC square if we apply the Pythagoras theorem. So that is what we will write, equal to AC square over AC square. Why? Because in right triangle ABC, AC square equal to AB square plus BC square. How we got that? By using Pythagoras theorem. So AC square will be 1, and therefore what result we get? We get therefore sine square theta plus cos square theta will give us 1. So this is one of the identity which we are having class 10th. Another identity which we can have is what we can do is, suppose we divide both sides of this identity by cos square theta. Let us do that. Dividing both sides by cos square theta, we will be getting sine square theta. So this will be sine square theta over cos square theta plus cos square theta over cos square theta equal to 1 over cos square theta. And you all know that sine theta over cos theta is tan theta, so here we will be getting tan square theta plus cos square theta over cos square theta, that will be 1 equal to, what is 1 by cos? That is sec. So we will be getting sec square theta. So the other identity which we are getting is 1 plus tan square theta, or tan square theta plus 1 is equal to sec square theta. Now what we have done in this, suppose this is equation number 1, we have divided equation number 1 or the identity 1 by cos square theta, but instead of this, suppose we divide both sides by say sine square theta, then what we will get in that case? So let's rewrite this again. So we have sine square theta plus cos square theta equal to 1. Now dividing both sides by sine square theta, therefore what we will be getting is sine square theta over sine square theta plus cos square theta over sine square theta equal to 1 by sine square theta. And we know that if we divide the same quantity with itself, what we get is 1 and should be non-zero here. So we'll divide sin square theta with sin square theta, we'll be getting 1 plus cos square theta over sin square theta, that is tan square theta, equal to 1 by sin square theta is, that is cosec square theta, because we know that 1 by sin theta is cosec theta, so we are getting cosec square theta. So what result we got ultimately? 1 plus tan square theta equal to cosec square theta. So this is our third identity. So what are the identities we have learned? First one is sin square theta plus cos square theta equal to 1. Second is tan square theta plus 1 equal to sec square theta. The third one is 1 plus tan square theta equal to cosec square theta. Now let us go in exercise 8.4. So 8.4 question number 1, which we are having is express the trigonometric ratios in sin A, sec A and tan A in terms of cot A. So we have to express sin A as well as sec A and tan A all in terms of cot A. So let us try solving this one. So we will be solving question number 1 of exercise 8.4. Now sin A can be written as 1 by cosec A, and we already know, we have seen that 1 plus cot square theta is cosec square theta. So this can be written as equal to 1 over root of 1 plus cot square A. Why? Because 1 plus cot square A is cosec square, and we take the root of that, we will be getting cosec A. So we have written sin A in terms of cot A. So first part is complete. Now let us see sec A. How we can write sec A in terms of cot A? So sec A, we know that is equal to 1 plus tan square A is nothing but sec square A. So if you take the root of this, we will be getting the value equal to sec A. So sec A can be written as square root of 1 plus tan square A. But we have to write sec A in terms of cot A, and also we know that tan A can be written as 1 by cot A. So we can rewrite this as 1 plus 1 by cot square A, and this can be written as cot square A plus 1, we will take the root of this, over, if you take the root of cot square A, what we will get is cot A. So this is our answer of sec A, and to write tan A in terms of cot A is very simple. Tan A is equal to 1 by cot A. So this is the answer of question number 1. Next we will be going question number 2. So what is question number 2? Write all the trigonometric ratios of angle A in terms of sec A. So what here we have to do is, we know there are 6 trigonometric ratios: sine, cos, tan, cot, sec, cosec. So what we will be doing, that we will be writing, sec is already given here, the remaining we will be writing in terms of sec A. So let us start solving question number 2. So solution 2, let us take sine A. So sine A can be written as, sine A we have to write in terms of sec A. So sine A can be written as root of 1 minus cos square A, because sin square A plus cos square A is 1, and sin square A is equal to 1 minus cos square A. So if you take the root of that, we will be getting sin A. Now cos can be written in terms of sec, so this we can rewrite as 1 minus, we know that cos A is equal to 1 by sec A. So this is 1 by sec A, because it is square, so we will be putting here square, and we will, on solving it, we will be getting sec square A minus 1, just we will take the root over this, and square root of sec square A will give us sec A. So sin A can be written as square root of sec square A minus 1 over sec A. Now what about cos A? Cos A is very simple. Cos A is equal to 1 by sec A. And how to find tan A? Tan A is also very simple, because we know that tan A can be written as sin A by cos A. Already we are having the value of sin A in terms of sec A. So sin A is square root of sec square A minus 1 over sec A, and we are having here into cos A. So sec A and cos A will cancel each other, and we will be getting equal to square root of sec square A minus 1. And another way which we are having is, now directly also we could have written here, because we know that 1 plus tan square A equals sec square A. From that also we can write the value of tan A. The choice is always many. You can write the way convenient to you. Next, we need to find the value of cosec A in terms of sec A. So we know that cosec A is nothing but the reciprocal of sine A. So cosec A equal to 1 by sine A. Already we are having the value of sine A in terms of sec A. So we'll take the reciprocal of this. So that will be sec A over square root of sec square A minus 1. So this is the answer of cosec A. Now next is cot A. Cot A will be nothing but the reciprocal of tan A. So cot A equal to 1 by tan A, and that is equal to 1 over square root of sec square A minus 1. So this is 1 sec square. So what answer we are getting is cot A equal to 1 over root of sec square A minus 1. So with this, question number 2 is also complete. Next we will go in question number 3. So what is question number 3? Evaluate sine square 63 degree plus sine square 27 degree over cos square 17 degree plus cos square 73 degree. So we will be solving the first part of question number 3. Solution first part, sine square 63 degree plus sine square 27 degree over cos square 17 degree plus cos square 73 degree equal to, now what identity will apply is, we know that sine square theta plus cos square theta is equal to 1, but here the values of theta are different. So what we can do is, we also know that sine theta can be written as cos 90 minus theta, so that is what we will apply here. So this can be written as sine square 63 degree plus, now this sine square 27 degree we will write in terms of cos, so that can be written as cos square is already there 90 minus theta. So theta in our this case is second part is 27 degree. So 90 minus 27 degree over, same we'll do in the denominator, we can convert any one of them into sine. So suppose we'll be converting the first one in terms of sine. So cos square 17 degree can be written as sine square 90 minus 17 degree plus cos square 73 degree. So second part will keep as it is, and this can be written as sine square 63 degree plus cos square, now 90 minus 27, that is 63 degree, over, same way in the denominator will be getting sine square 90 minus 17, that is 73 degree, plus cos square 73 degree. So now we can use the identity, that is sine square theta plus cos square theta equal to 1. So it is a must in that is the angle which sine and cos include, that should be the same. So here for sine as well as cos we are having the same angle, that is 63 degree. Same in the denominator we are having the same angle 73 degree for sine and cos. So we can write the numerator here 1, and in the denominator also we can write 1. Why? Because sine square theta plus cos square theta is equal to 1. So therefore what we can say that the value of this is equal to, because 1 over 1 is 1. Now let us do the second part. Second part we are having is, we have to evaluate the value of sine 25 degree into cos 65 degree plus cos 25 degree into sine 65 degree. Here also we will do the same thing. We will convert one of these in terms of cos and here one of them in terms of sine, so that we can use the property of, or the identity of sine square theta plus cos square theta as 1. So solving second part, sine 25 degree can be written as sine 25 degree keeping as it is, and this cos 65 degree we can write as sine 90 minus 65 degree, plus here we will keep cos 25 degree as it is, and the second, that is sine, will convert in terms of cos, so that can be written as cos 90 minus 65 degree. So simplifying it, we will be getting equal to, so this can be written as sine 25 degree, now 90 minus 65, that is 25, so we will be getting here sine 25 degree plus cos 25 degree multiplied by here also cos, there 90 minus 65 is 25 degree, So this we can rewrite as sine square 25 degree plus cos square 25 degree, and that is equal to 1. Why? Because of the identity, that is sine square theta plus cos square theta equal to 1. So with this our question number 3 is also complete. Now let us go in question number 4th one. So 4th one, we are having one by one. Let us take the first part. Question number 4th, first part. Solving 4th one, first part. What we are having is 9 sec square a minus 9 10 square a equal to 9 can be taken out common, sec square a minus 10 square a equal to, from our study of identity we have seen that sec square a can be written as 1 plus 10 square a. So we can rewrite the sec square as 1 plus 10 square a and keeping this minus 10 square a as it is. So 10 square plus 10 square a minus 10 square a will cancel each other and we will be getting 9 into 1, that is 9. So the answer of first part is option number B. Next we will be doing second part of question number 4. So second part, 1 plus tan theta plus sec theta multiplied by 1 plus cot theta minus cosec theta. So equal to, we can rewrite this as 1 plus tan theta plus sec theta and 1 plus cot theta minus cosec theta. Let us multiply and divide this with 10. So we'll see what we'll get on doing this one, equal to, so we'll be getting here 1 plus tan theta plus sec theta. So multiplying with 10, we'll be getting here, this will become tan theta plus cot theta into tan theta, that is 1, and minus cosec theta. Minus cosec theta is actually 1 by sin theta, and tan theta is sin theta by cos theta, and the whole divided by tan theta. So this is what we are getting, and here what we'll get is this sin theta and sin theta will be cancelled out. The next step will be getting equal to 1 plus tan theta plus sec theta multiplied by, this will be given as 1 plus tan theta, and here we'll be getting minus 1 by cos is sec theta, so minus sec theta, the whole divided by tan theta. Now what we can do, we can take 1 plus tan theta as a, this we can group 1 plus tan theta, this whole we can write as a and this is b. So what we will be getting here is a plus b into a minus b. So equal to 1 plus tan theta whole square. This can be written as not whole square, this will be this can be written as a plus b into a minus b. So we will be getting a plus b into a minus b, that is a square minus b square. So definitely it will be square will be here. So and minus, we can write here sec theta, that is sec square theta over, this will be tan theta. Now what we have got here is, again let's see that a plus b into a minus b, that is a square minus b square. So what is our a? Our a is 1 plus tan theta and b is sec theta. So next we will apply the formula of a plus b whole square. So that will be equal to a square plus b square plus 2ab, that is 1 plus tan square theta plus 2 tan theta minus sec square theta over tan theta. Now equal to, also we know that 1 plus tan square theta will be same as sec square theta, but they are of opposite sign, so because minus here, so equal to, we will be getting sec square theta plus 2 tan theta minus sec square theta over tan theta. Why? Because 1 plus tan square theta is same as sec square theta. So we will be cancelling them, sec square theta minus sec square theta will cancel each other, and what we will be getting here is, also we can see here, we'll be having 2 tan theta over tan theta. So we can cancel this tan theta also from both numerator and denominator, and finally what answer we are getting is equal to 2. So the final answer is equal to 2. So the answer of question number 4th, second part is C, that is 2. Now same concept we can apply here also, or the other way is that you can convert sec a plus tan a both in terms of sine and cos and then simplify it. So let us do this third part. So question number 4, third part, that is sec a plus tan a into 1 minus sine a. Third part, sec a plus tan a multiplied by 1 minus, so sec a plus tan a we have to multiply it by 1 minus sine a and see what is the result. So sec a plus tan a into 1 minus sine a. So now what we'll do is convert sec a and tan a both in terms of sine cos. So sec a can be written as 1 by cos a plus tan a can be written as sine a over cos a into 1 minus sine a, and this we can write as equal to 1 plus sine a over cos a and multiplied by 1 minus sine a, and this can be written as, again we can apply the formula of a plus b to a minus b, so we will be getting 1 square minus sine square a over cos a, and 1 minus sine square a is nothing but cos square a, so cos square a over cos a, and that will give us equal to cos a. So the answer of question number 4, third part, will be cos a. So cos a is written here, yes. Also option D is correct. So option D is the correct answer. Now let us do question number 4, fourth part. It is 1 plus tan square a over 1 plus cot square a. So fourth part, let us do the fourth part. 1 plus tan square a over 1 plus cot square a equal to, what is 1 plus tan square a? That is sec square a. What is 1 plus cot square a? That is cosec square a. And this also will be writing in terms of sine and cos. So 1 by cosec we know that is equal to sine square a. So this can write as sine square a, and sec square a we can write as 1 by cos square a. So finally we will be getting sine square a over cos square a, that is tan square a. So 1 plus tan square a over 1 plus cot square a is nothing but tan square a. So the correct option in this case is D. So with this question number 4 is complete. Next we will go in question number 5. So question number 5, exercise 8.4, first part. We have to prove that cosec theta minus cot theta whole square is equal to 1 minus cos theta over 1 plus cos theta. Now there are different ways of doing it. We can solve the, we can start from the LHS and reach the RHS, or we can solve the RHS and make it equal to the LHS, or we can solve both LHS and RHS half-half and then equate them. So these are the different ways of solving it. You can use any method. So let's start doing question number 5, first part. So solving first part, solution 1. So I will be solving the left hand side. So what we are having is, there is cosec theta minus cot theta whole square, and cosec theta we can write as 1 by sine theta minus cot theta can be written as cos theta by sine theta whole square, and this we can write as 1 minus cos theta whole square over sine square theta, and this can be written further as 1 minus cos theta whole square over, because we have sine square theta plus cos square theta, this identity we are having, sine square theta plus cos square theta equal to 1. Therefore, we can write sine square theta as 1 minus cos square theta. So that is what we can apply it here. We can write this as 1 minus cos square theta, and this further can be written as 1 square minus cos square theta. So we will be getting here equal to, the numerator we can write as 1 minus cos theta into 1 minus cos theta over and denominator we can use the formula of a square minus b square, that is a minus b into a plus b. So 1 minus cos theta into 1 plus cos theta. So in both numerator and denominator we are having the term 1 minus cos theta common, so we will be getting equal to, the final answer which we are getting is equal to 1 minus cos theta over 1 plus cos theta, and that is, this is equal to 1 minus cos theta over 1 plus cos theta. So this is what we have proved. So what we have got the final conclusion, that cosec theta minus cot theta whole square is same as 1 minus cos theta over 1 plus cos theta, hence proved. So this is the proof of question number 5, first part. Next we'll do question number 5, second part. So here we are having question number 5, second part. Cos a over 1 plus sin a plus 1 plus sin a over cos a, that we have to prove is equal to 2 sec a. So I will be solving here the left hand side and try to prove that is equal to the right hand side. So solving question number 5, second part. Solution 5, second part. Cos a over 1 plus sin a plus 1 plus sin a over cos a, and equal to, this we can write as cos a over 1 plus sin a multiplying and dividing with 1 minus sin a. Here also we will be multiplying with 1 minus sin. So multiplying and dividing with 1 minus sin a plus 1 plus sin a. In second part also, let us multiply and divide with the say same value. We'll multiply with the conjugate 1 plus sin, that is 1 minus sin a, multiply and dividing with 1 minus sin a. So equal to what we can get is cos a into 1 minus sin a over 1 plus sin into 1 minus sin a. So that will be cos square a, and plus 1 plus sin into 1 minus sin a, that is cos square a over cos a into 1 minus sin a, and this can be written as equal to, now here we are having cos a, in the denominator we are having cos square a, so we can rewrite this one as cos a into 1 minus sin a over denominator we can write as cos a into cos a, plus same way cos square a we can write as 1 minus sin square a. So writing cos square a as 1 minus sin square a. Why? Because cos square a plus sin square a is 1, divided by cos a into 1 minus sin a, and this further we can write as equal to, here we can cancel cos a and cos a, so first part we can write as 1 minus sin a over cos a, plus second part we can use the formula of a square minus b square, because 1 can be written as 1 square, so we will be getting here 1 minus sin a into 1 plus sin a, the whole divided by cos a into 1 minus sin a. Here also we can see that in both numerator and denominator 1 plus sin is common, so that we can cancel out, 1 minus sin a is common, so we'll be cancelling that out. So cancelling 1 minus sin a both part, and this will rewrite, so that is 1 plus sin a. So finally what we are getting is equal to, next step, whenever the denominator same we can add the numerator, so equal to 1 minus sin a plus 1 plus sin a over cos a. Now cancelling minus sin a and plus sin a, so remaining will be getting, adding the like terms, 1 plus 1, that is 2, so we are getting 2 over cos a, and that is equal to, because 1 by cos a is sec a, so this can be written as 2 sec a, and this is what we have to prove. Yes, because we have to prove that cos A over 1 plus sin A plus 1 plus sin A over cos A is equal to 2 sec A. So this is the proof of question number 5, second part, and with this it is complete also. So that is what we will write, hence proved.